So precision and recall are two core metrics that we'll see all the time later on when we do more machine learning. Here, we are now going to look at a few more metrics that are very specific to recommendation systems. And one of them is a variation on precision called precision at k, where k is a cutoff. So this is for the special case that you want to look at a ranked list of recommendations. Yeah, we don't just give a set of 10 elements. We say this is number 1, 2, 3, 4, 5, 10. Yeah, just like in a ranked list of search results, for example. And now we limit our evaluation to the top k results. So typical example could be the top 10. The motivation is that for a user, it's not really relevant what the precision is when you evaluate it over millions of items. If you look at websites like Amazon or Netflix, they really have millions of items that they could recommend. But a recommender algorithm is really only good if the top recommendation it gives you are the ones that you're really interested in, because you look at the first 10, maybe even the first 20 or 30, but you're not going to look at a few 100,000 recommendations. So this is why this precision at cutoff k is very important for recommender systems, because here the good recommendations have to come high in the list that it shows you, and not at the very end of the list. So how do you compute it? So this is called the precision at k, and it's simply 1 over k multiplied with the sum over looking at each item in the list and saying if it's relevant or not. So if you have 10 items, you check out the first one. Is it relevant? Then it's 1, not it's 0. So it's basically a sum, 1 plus 0 plus 1 plus 0 plus 1, depending on whether an item was relevant or not. And then you divide it by k, and that's the precision at k. So intuitively, what it tells you is what's the percentage of correct recommendations in the top k, for example, in the top 10. You might wonder, okay, that's precision at k. Is there also recall at k? Well, not really, because in this kind of application, we don't really care about recall. Again, if you think of websites like Amazon or Netflix, they have millions or even hundreds of millions of items. And we really don't care if we could get 150 million recommendations or 260 million recommendations. This is more than you could watch in your lifetime or in 3 lifetimes. So in this particular scenario, recall isn't really interesting. We'll see later other machine learning techniques and approaches where recall is very important, but here in the context of recommendation, we are mostly concerned about these precision metrics. So to make sure you understand how to calculate precision at k, there is another task on the worksheet, and then I'll see you back for the next evaluation metric. Good luck.